Hello YouTube, it's the Middle School Math Man. Today's video is on domain and range of functions. And these specific examples I'm going to go over, these are continuous graphs. So these can be a bit confusing at first. You kind of have to use your imagination a little bit on some of these. So just real quick, we know that domain, those are going to be my x values. Range, those are going to be my y values. So let's take a look at this graph. So as you can see by the arrows, that means that these lines are going to stretch forever and ever and ever. So if you want to imagine this graph just continuing out and up forever and ever, that's what we need to kind of think about. So when I'm looking at my domain, when we write it, we are going to use the set builder notation. So I suggest kind of just setting up the frame first, so then we can really, just plug in numbers, because we already have the frame set up. So domain, that's my x-axis, my horizontal axis. So if these lines continue out and up forever and ever, it's just going to keep spreading wider and wider and wider. So this graph, every single x value is going to be a part of the domain. Again, the graph's going to stretch out forever and ever. So we're going to represent that using our set builder notation. So this is how we're going to represent all real numbers, what I just drew there. So this says that x is greater than negative infinity. You can never reach infinity. That's just kind of a, just some idea. So we are going to have x is greater than negative infinity, but x is less than positive infinity. So that's how we're going to represent all real numbers. So my range, those are my y values, so my vertical axis, which I'm highlighting in red. I'm concerned with the y-axis. So let's take a look. The lowest point on this graph, on the y-axis, I'm highlighting in green. That is at y equals negative 5. That's the lowest point on the graph. There are no points below y equals negative 5. So when I'm writing my range, again, it's going to be in set builder notation. Notice how I have a y instead of an x because range, those are my y values. So y equals negative 5 is the lowest point on this graph. So that means that y has to be greater than or equal to negative 5. That's what I have right there. Y is greater than or equal to negative 5. It can be negative 5. As you can see, it's a point on y equals negative 5. So it can be negative 5. So it can be greater than or equal to negative 5. And again, these lines, they go up and out forever and ever. So every single y value greater than negative 5 is also going to be represented in this graph. So we're going to have y is less than infinity. Again, you can't reach infinity, so we're not going to have y is less than or equal to infinity. We're just going to have y is less than infinity. And if we're looking at the vertical line test, again, we're going to take our pencil from the left and work our way to the right and see if the graph hits my pencil at more than 1 point. And it does not on this graph, so yes, that would be a function. Let's move on to the next example. So this is just, a straight line. So my domain, again, set builder notation. So this graph is just going to continue, just like the other one. It's going to continue on and on forever. So every single x value is represented in this graph because it's just going to spread out forever and ever. So we're going to have our infinities here. So x is greater than negative infinity, but x is less than positive infinity. And that's how we represent all real numbers. My range, so we're looking at the y-axis now. Again, this graph spreads out and up and out and down forever and ever. So we're going to have all real numbers also for my range. So we're going to represent it using our negative infinity and our positive infinity. So y is greater than negative infinity, but y is less than positive infinity. And according to the vertical line test, this is a function. Two more examples. So here, when we're looking at my domain, again, it's my x-axis in green. So I'm going to set up the frame, the set builder frame. So we are looking at the x-axis, and there is nothing to the left of that point right there that I just drew. And that point is at the origin, which is x equals 0. So x has to be greater than or equal to 0. 0 is the furthest left point. And obviously the arrows pointing to the right are going to mean that every other x value is going to be included in this graph because those lines spread out forever and ever. So x is greater than or equal to 0, but less than infinity. They go on forever and ever. You can never reach infinity. So that's how I'm going to represent my domain. Looking at the range, in red, we're concerned with the y-axis. So these lines, again, are going to spread up. It's just going to keep gradually getting, taller and shorter. These lines are going to continue going on forever and ever and gradually just getting wider and wider and wider. So every single y value is included. So you're going to see a lot of times this representation or this answer that I'm just doing in the range right there, you're going to see that a lot of times, as you can tell. And that's just another way of writing all real numbers. So y is greater than negative infinity but less than positive infinity. And then if we're doing the vertical line test, let's just see. If our pencil was on x equals 2, which I just drew, as you can tell, it hits that line at 2 points, so that is not going to be a function. Last example for this video. This kind of looks like a little funny example here. So my domain, my x values, so these lines, they're very steep, but gradually they're going to continue to get wider and wider. Ever so gradually, they're going to continue to get wider and wider and just keep spreading out. So we're going to have, again, that representation for all real numbers that keeps popping up. X is less than infinity, but greater than negative infinity. So now let's take a look at the range. This graph, so again, my range is my y-axis in red. The lowest points on the y-axis are those 2 points that I'm highlighting in red. That is at y equals 0. So there are no points in this graph less than y equals 0. So when I'm representing that, again, I'm going to have my set builder frame. Y has to be greater than or equal to 0. There's nothing that goes below y equals 0. So y has to be greater than or equal to 0. And these lines, again, they're going to go up forever and ever. So y is going to be less than infinity. Vertical line tests, moving my pencil from the left to the right. It never hits at more than 1 point, so yes, that is a function.